Hello friends, in this video I am going to discuss different data types like arrays, tables, data frame, lists. Now first of all, array. To store the data efficiently we can create an array. Okay. Now to create a 3x4 array, say 2-dimensional array, so we have to write the syntax like this way. The data and the dimension. Okay. So 3x4 array, so dimension. Okay, so it's 2-dimension. Now 3 rows are there and 3 rows are there and 4 columns are there. Okay. Now to access an array we can write like this way. So third row and second column, third row and second column, that is 6. Similarly you want third row, fourth column, should be 12. Okay. Now we can create 3-dimensional array also. Now to create 3-dimensional array, say total should be like this way, 2, say 3 into 3 into 2, sorry, okay, so 2 into 2 into 3, x, okay. So 1, 2, 3, 3 parents are there, so we assume that is 3 parents are there, parent 1, parent 2, parent 3. Now each parent there should be a 2 by 2 matrices, 2 by 2, 2 by 2, 2 by 2. Okay. So this is a 3-dimensional array. Now to access 3-dimensional array we may write like this way, say third rows, sorry, say first row, second column, second parent. Okay. So that is a 7, so you can easily cancel. Second parent is this one, first row, second, that should be the 7. Okay. So first row, second column of parent second, so parent 1, parent 2, first row and second column, that is 7. Okay. Now next, table. Now tables are widely used to summarize the data. Suppose the data is like this way, say yes, no, yes. Okay, now do it quickly. Okay, so T holds data. Now if you write table of T, so you can see how many nodes are there, 2 nodes are there, no 1, no 2, and how many yes are there, 4 yes are there, so yes 1, 2, 3, 4. Okay, so we use table for summary purpose, clear? Now similarly we can write like this way also, say 3, 4, 7, 7, 7, 8, 5, yes, 0. Now we can write table also, table T. Okay, so single 0, 3 1, 1 3, 2 5s are there, 2 5 are there, okay, 3 7 are there, that's what is 3, and 8 is single 8 is there. Clear? So in this way we can create table and we can use table. Now next data type is data frame. Now a data frame is used to store rectangular grids of data. Okay, so data frame must be variable of the same length. The collection of entries need not all be of the same type, for example numeric, character or logical, but each column must contain the same type of entry as there are data vectors. Clear? So collection of data vectors. So first of all create two data structures. Say x1, 2, 3, it holds the integer type data, y holds character type data, say a, b, c. Okay, now we can create data frame for that. Data frame x comma y. Okay, now if you press Z, you can identify that this particular data type can handle different data types. Okay. Now data frame can store different types of data, say numeric as well as character. Now to identify the vector names, we just write names of set. Okay, so two are there, x and y. So x and y. Now to know the dimension of the vector, we have to write dimension of set. Okay, so 3 rows are there and 2 columns are there. 3 rows are there and 2 columns are there. Now to print the second column, okay. Now to print the second column, we have to write like this way. Okay, A, B, C. So nothing comma, nothing means print all the rows, second column only. Okay. Similarly, we can print first row all the data. So there is 1 and A, first row all the data. Similarly, we can print the particular data, say second row first data, so it should be the 2, second row and first data. Okay. Now we can modify the content of the data frame also. Okay. Now suppose we want to modify the content of second row and first data. Instead of 2, second row first, it should be the 22. So you can write the 22. Now if you can print 1 second, now you can see that the second row and first data should be the 22. Now to check the entry, we can use this one. Suppose second row of first data, is it 2? Only 2? It is false. Is it 22? True. Okay, so we can perform some logical operation also. Next data type is list. Now a list is a general type of storage. A list is a collection of components, and each component can be any R objects like a vector, a data frame, a function, or just another list. Now to declare a list, we use this syntax. List, suppose first it contains integer type, say it is 1 is to 3, so we have to write like this way, sorry, y is equal to letter and z is equal to sequence. Now w you can see, so w $x is 1, 2, 3, w $y is this one, w. Now particular data also, suppose 2 is b, similarly w z remaining data. Yeah, now we can write length of w $z, it is 41. Clear? Now we can modify the content also. Suppose w $x, second one is 2. Now we want to modify this one, so we have to assume it is 23. Now we can see that the second will be the 23. Okay, so we can modify the content of the list also. Finally, the last data vector is factors. To store numerical data, we use factor data type. The factor stores the nominal values as a vector of integers in the range 1 to m, where m is the number of unique values in the nominal variables. Clear? Now, okay, now just for example, we have write a, okay. Now alpha stores a, e, b, c. Now we can write alpha rank is equal to factor alpha. Okay, now we can print alpha rank. So levels are A, B, C, D, E. The actual data A, E, D, C. So we can print the level of this particular to show the rank numerically. So we have to write as numeric alpha rank. Okay, so A first data here, E fifth data, D fourth data, V second data, C third data. Okay, so in this particular video we have seen that different data types: arrays, table, data frame, list, okay, and factors. Clear? That is the end of this particular video. Thank you.